Okay, here we have the bromination of ethylbenzene, and we need the problem 6.51 is first predict the product for the reaction and then draw a mechanism for it. And if we think about what type of mechanism it is, since it's a bromination with NBS, it's a free radical process, so we need to think about what kind of hydrogens we have on our molecule. And we have the primary hydrogen here on the end. We have a secondary benzylic hydrogen here on the carbon right off the ring, and then we have the 5 hydrogens that are aromatic on the ring itself. And remember what we've said in class, to never touch the aromatic ring because we're in org 1, and in org 1 we never touch the aromatic ring. So we have our choice of the secondary benzylic hydrogen or the primary hydrogen. And we all know that free radicals are electron poor like cations, so the more substituted the free radical is, the more stable it is. So our product should be the bromination on the benzylic carbon, and we'll draw a mechanism for it all, starting with the initiation, where the bromine, and we'll start from Br2 just to make the mechanism easier. The initiation, we form the bromine free radical, and then we need to propagate the reaction. And there will be 2 propagation steps at least that we'll need to draw. The first one, where an equivalent of bromine free radical will abstract a hydrogen off of the benzylic carbon to give us our benzylic radical. It's the most substituted radical that can form, and we can draw resonance structures. We can draw 4 resonance structures for this cation to show why it's, or this radical to show why it is so stable. And then once we've formed the radical, we can have it react with the molecule of Br2 to abstract a bromine off of it to get to our desired product of the bromine on the benzylic carbon. And then we can terminate the reaction where 2 free radicals, and any 2 free radicals that you showed in your mechanism can come together to form a small whole molecule. Now, the resonance structures, we'll draw them at the bottom of the page since there is room. Since it's a free radical process, we need to show all of the electrons moving with fishhook arrows. So the first resonance structure puts the radical inside the ring, and then we keep moving the electrons around the ring so that in the next one we get our radical there, and then we can move it 1 more position to there, and then we can finish it by sending the electrons back to where we started, or the electron back to where we started, and we get our benzylic compound. And remember, when you draw resonance structures, you have to show the resonance arrows in between each structure and show the movement for all electrons in that little arrow right there is a little small. So there we have the mechanism and the resonance structures for, I lost a methyl, sorry, the compound.